Welcome to my channel. In previous video we saw how to solve number of provinces. Now in this video we will see how to solve rotten oranges. So without wasting time, let's get started with this question, that is rotten oranges. So first let's understand the problem statement, and after that we will move towards approach, intuition, dry run, pseudocode and code. Okay, so let's understand the problem statement. What problem is saying, like we have a 2D grid as shown here. As you can see, this is a 2D grid. In this grid, 0 represents an empty cell, while 1 represent a fresh orange, while 2 represents a rotten orange. Now every minute any rotten orange will be rot its adjacent fresh orange. So we need to find the minimum number of minutes required to rot all these oranges. That means if this is a rotten orange, it means 2 means rotten oranges, then it will rot its adjacent oranges. So we need to find the minimum number of times so that all these 2D grid got rot. Okay, so if it is not possible, so we need to return -1. So coming to intuition, like this, if you think this problem is not a simple BFS problem, it is like a multi-source BFS, then you will definitely ask why it's multi-source BFS problem. Because we don't start from just one node. Okay, we don't start from that just one node. We start from all rotten oranges at the same time. Okay, let's take another example. Like in a grid, if we have something like 2 2 1 2 1 2 and something like this is the grid. Okay, so what we will do, we will start from all 2. We push all the 2 inside a queue, and after that we start BFS traversing, and so on process. I will discuss all the process later in this video. So first understand this problem, then what's our intuition, that this is not a simple BFS, this is a multi-source BFS. And I discussed why it's a multi-source BFS, because we don't need to start from this single node, we need to start from all the rotten oranges. That's why it's a multi-source BFS. So like connect it with a real-time example. Like if you don't understand, let me connect it with a real-time example so that you can get it easily. Like this problem you can connect with like a infection. Okay, like 2 means infection, all rotten oranges spread simultaneously. That means, infection is spread itself. So that means if this is 2, then this will definitely spread itself. This will definitely make oranges, its adjacent oranges 2. That means if it is 1, it will definitely make it 2. So the condition is that in every minute, each level of BFS represent 1 minute of time. You can observe from the question that for every traversal of BFS, you have a 1 minute. Okay, so think of like this is level 0, this is level 1, this is something like all the levels. Okay, so think of like level 0 is like initial rotten oranges, level 1 is like newly rotten oranges, level 2 like further spread itself. Okay, that's how we can track the time. So I hope you got the problem statement. You will definitely get that intuition, why it is multi-source BFS, and what's the thought process, what will be our thought process for this particular problem. So coming to pseudocode, before coming to pseudocode, let's convert our intuition into the steps. That means we will definitely go through the approach. So let me discuss step-by-step logic to solve this problem. So what is it mean? Like, wait, let me resolve this thing, and after that I will discuss my approach and so on. Okay, so what we need to do, like if I'm asking you what we need to do, we need to traverse this grid. Okay, we need to traverse this grid. We need to add all the rotten oranges into some data structure. If we are using BFS traversal, then that data structure will be queue. So what we need to do, we need to traverse this over this all grid, that means over this grid, and whenever we found that particular 2, that means we need whenever we found that this orange is rotten, that means we need to put it inside queue. And if we find any, like if we found one, like this is a fresh orange, so we need to count that. So we need to keep track of two things. First one is that queue. So whenever we find that this particular uh, orange is rotten, so we need to put it inside a queue, and a fresh variable that will count the number of total number of fresh oranges inside this grid. Okay. So and after that, what will be our second step? After doing all this thing, we will start BFS traversal. What we will do, we will start BFS traversal. We will process level by level, and also I have discussed that each level has 1 minute. So for each rotten oranges, this is the important point which I need to explain. For each rotten oranges, we need to check its adjacent. That means we need to check in all four directions. If fresh orange is found, then we need to make it rotten, put it inside a queue, reduce the fresh count. Wait, let me ask you one thing. What is the total number of fresh oranges inside this grid? 2 plus 2 plus 2. You will say 6. Yeah, definitely. 6 is the total number of fresh oranges inside this queue, inside this grid. I will push this 2 inside a queue. So let me take a queue, and I will put 2 inside this queue. Okay, good. What we will do, I will check in all four directions of this 2. This will be invalid, this will be invalid, this will be valid, and this is 1. That means it's a fresh orange, so we can route this. So we will make it 2, and we will decrease it from 6 to 5. Now this will be also a valid. So what will we do, we will simply make it 2, and we will decrease it by 1 and make it 4. Okay. So we need to continue this process until no fresh oranges left. That means if whenever we find that fresh oranges, count of fresh oranges equal to 0, then we will simply stop this BFS traversal. Or whenever queue got empty, we will simply put ourselves out from this process. And whenever we find that fresh oranges is equal to 0, then we need to return time, else we need to return -1. That's overall approach. That will be the approach for solving this particular problem. So let me come to pseudocode, and let me show you a pseudocode, and after that I will discuss I will do a dry run for this particular grid, and after that we will write the code for solving this particular problem. Okay, so let me show you. Okay, what we need to do, we will simply create a queue as I discussed. We will create a queue, we will count the fresh oranges as I discussed. We will push all rotten oranges into a queue. Yes, we will initialize a time variable. Okay, and check whether queue is empty or not, or fresh is greater than 0. Then what we will do, we will take the size of the queue for all element inside this label. We will check for all the four directions. If the oranges are rotten, then if the oranges is not rotten, it means if it's fresh, then we will rotate, push it inside a queue, decrease the fresh. Otherwise that means and after that we will increase the time, and we will check in the last that if fresh is equal to 0, then we will return the time, otherwise we will return -1. So I think this is messy. So let's see a dry run, let's do a dry run so that everything become crystal clear. Okay, let me confirm. Okay. Okay, this is a queue, and what we need to do, we need to keep track of fresh oranges. So we will take a variable fresh. Okay, and also we need to take a time variable. So let me take a variable time. Initially it will be 0, and So what we will do, we will iterate over this grid. When we iterate over this grid, we have to check whether grid of I and j equal to 2. So we found that grid of 0 and 0 is equal to 2. Yes. So what we need to do, we need to push I and j inside this queue. So what we first step is we need to iterate over this grid. So after that we find that we need to post 0 comma 0 inside this queue. Okay, done. Okay, and if that particular grid ij equal to 1, then what we need to do, we need to increase the count of fresh. So fresh will be 1 for this. 2 is inside grid, fresh we increase, another fresh we will definitely increase fresh, another fresh increase, another fresh increase. This 0 means empty, this 0 means empty, another fresh increase, another fresh increase. So the total number of fresh oranges will be 6, and there isn't any kind of rotten oranges except this one. So we have a variable time. We need to check, we have a condition, we need to check whether q is empty or not. Yes, q is not empty. So another condition will be whether fresh is greater than 0. Yes, the total number of fresh oranges is 6 this time. So what we need to do, we need to find the size of the queue. So what is the size of the queue? This is 1 this time. So we will iterate from 0 to 1. Okay, what we will do, we will iterate from 0 to 1. That means we will iterate for 0, and before iterating we will increase this count. Okay, so let me describe again so that you can get it. What we had done, we iterate over this grid, we check whether grid of ij equal to 2, we will put push I and j inside q. If we have 1, then we will increase the fresh, otherwise if 2, otherwise 0. If 0, this is that means empty cell. If 2, we will push it inside q. Okay, so that's done. So what we need to do now, we need to find the size of the queue. Here size of the queue is 1, and we will increase the time. Time become 1, and now what we'll do, we will iterate from equal to 0 till size minus 1, and what we will do, we will find the front element. That means we will find the value of I and j. That means what will be I, that is our q dot front dot first will be I, and what will be our j, that will be q dot front dot second. That's done. Now what we'll do, we will simply pop it. That means the value of I and j is 0 and 0. We will pop it. It will become, this time the queue become empty. Okay, now we need to check in all 4 direction of this particular I and this particular node. Okay, so what for this, what we will create a direction arrow, direction of x and direction of y. That means I will describe that inside code actually, that what will be direction. For a dry run, let's understand that I have to check for up, down, left and right. Okay, all 4 directions. So what we'll do, we will take another loop, and we will go from 0 till 3. Okay, that means 0 1 2 3, that is the total number of direction will be 4. So now we will find the new row and new column. So our new row become I plus the direction array of k. So let me describe it. 0 plus direction of 0, the direction of 0. So let me take a direction array. Okay, so that everything becomes crystal clear. So wait, let me take a direction array dr, that means direction of row, that will be initially minus 1 0 1 0, and direction of column will be 0 1 0 and minus 1. So what will be our new row? We know that I is equal to 0. We found from this q dot friend dot front first. So I is equal to 0 plus dx of d r of k. That means dr of 0. Dr of 0 is 1. So 0 plus 1, that is new row will be 1. So we need to come here. We need to come in this row. And similarly, what we need to do, we need to find new column that will be j plus dc of k. So what will be our new column? We know that the value of j is 0 and dc of 0 is 0. So our column will be 0 and row will be 1. So that so we need to check for this. We need to rotate this element, this particular orange, because this is fresh orange. Okay, this is fresh orange. So what we need to do, we have some boundary condition like this new row and new column will be greater than equal to 0 and less than this the size of grid. Okay, less than the size of grid, like grid is of n cross m, so that so our new row and new column will be greater than equal to 0 and will be less than n and m. Okay, and also this grid of new row and new row column will be 1. Okay, so yes, it satisfies the condition. Our new row is 1, new column is 0. Okay, it satisfies the condition. Whether it's less than n and m, no, the value of n and m is 3. It is, yes, it is less than 3. So what we need to do, we will simply push this inside a queue. That means we will make it 2 and we will push it inside a queue, and this will become 1 comma 0 inside a queue. That's done. And what we need to do, we will reduce this, the total count of phrase, to 5. Now this become 2. That's done. Okay, now for this we need to check for this particular what will be now our k become 1. Okay, we know that I is 0 plus dr of 1 is 0. That means 0th row, and dr of dc of k, that means dc of 1 is 1. So for new this time new row will be 0 and new column will be 1. It satisfies the condition. It is less than n and m and it is greater than equal to 1 0. So what we need to do, we will simply mark it as 2 and put it inside a queue. 0 comma 1. Okay, and also we need to decrease this to 4. Okay, so the new grid is like, let me erase all this thing, and okay, the new grid is like 2 2. So now we need to check another time we will repeat this process, like queue is not empty. So what we will do, we will check it's 2. Yes, it's 2 now. So we will it is inside queue. So what we will do, we will find out the size of key and we will repeat until we wrote all these fresh oranges. So this is the overall process. Now for this this 2 will make this 1 2, and also this will make it, this will make it. Okay, and for every process, that means the time will for every iteration the time will be increases, itself, and this fresh count will be decreases for every one. Whenever every one becomes 2, this fresh count will be decreases, and for every iteration our time will be increases by 1. So if I will make all this trial, and then the video will be too long. That's why I have described only one iteration. You can do all the iteration by yourself so that you can get it easily. Whenever you will do by yourself, then you will definitely you will definitely boost yourself. Okay, so whenever you repeat process, let me explain it once so that you can do it by yourself. What we need to do, we need to iterate over this array, this grid. We need to check whether If grade of ij is equal to 2, then we will push I and j inside a queue. If grade of ij is 1, then what we will do, we will increase the phrase. And we will check whether queue is empty or not. If queue is not empty and phrase is greater than 0, so what we will do, we will find out the size of queue. And we will iterate till the size of queue to find the front element, find the element inside this queue. That means we will find the row and column in which row column that the 2 will be, and the 2 was. Okay, so we will iterate, and then we will iterate in all the 4 direction to find out the new row and new direction. And I will check a condition. If new row is greater than equal to 0 and new column is greater than equal to 0 and new row is less than n and new column is less than m and grid of I and j is equal to 1, then what we will do, we will simply grid of new row and new column make it 2, and also we will decrease the phrase. Okay, so that's the total intuition, that's the total approach, that's the total, that's the process of dry run. So do it by yourself so that you can easily get it. Let me write the code so that the video will not become too long. Okay, let me come to my VS Code, and after that I will write the code. Okay, that's done. We have NNM. We will iterate, like we have NNM, we have a grade. We will iterate over this grade. J is less than m, j plus plus. We will check if grid of I and j equal to 2, then what we need to do, we will simply push it inside a queue. Let me take a queue and place variable, all the variables. Okay, queue. Okay, phrase equal to 0 and a time variable. Okay, okay, and we will check else if grid of I and j equal to 1, then what we will do, we will simply increase the count of phrase. Okay, that's total, that's done. Now we will create a direction array. So int of dx4, what will be this? This will be -1 0 1 0. What will be our d of dy of 4? That is 0 1 0 -1. Okay, now we need to check, we need to call BFS, that while not q dot empty and another condition will be our phrase is greater than 0. So what we need to do this time, I will find the size of the queue. Okay, I will iterate from 0 till size -1, increase it by 1, and after that what will I do, I will find the row and column. That is q dot front dot first will be row and column will be q dot front dot second. Okay, now what we need to do, we need to pop it. Okay, also we forgot to increase that time, so let me increase the time. Okay, by 1. For every iteration we need to increase the time. Okay, so what we need to do, we need to iterate in all the direction, so that is less than 4 k plus plus. Okay, now our new row will be I plus dx of k. Our new column will be j plus dy of k, and we need to check a condition. If new row is greater than equal to 0 and new column is greater than equal to 0 and new row is less than n and new column is less than m and grid of new row and new column equal to 1, then what we need to do, we need to make it to grid of new row and new column will become 2 this time, and we need to decrease the total count of phrase by 1, and we need to put it inside a queue. That's done. Now what we need to do, we need to check if the total count of phrase is 0. If phrase equal to 0, then we need to return, that means we need to see out our time, we need to print our time, okay, otherwise we need to print -1. So this is the code. Let me check it once whether it's working fine or not. Okay, so let me run it once. g++ yt.cpp. Okay, hope everything is fine in this code. According to me, everything is fine this time. So let me check whether it's working fine or not. Let's see. Okay, let me give 3,3, okay, as input. 2 1 1, okay, 1 1 0, okay, 0 1 1. So the output should be 4. So let me check whether it's working or working fine or not. Yes, it's totally fine. That's the correct output, and we got our output as a 4. So this is the overall concept of routing orange problem. So today we learned multi-source BFS, grid traversal, level wise time tracking. So this is very important interview question. Make sure you practice it and try solving similar problems so that you become master. So we will meet in the next video. Till then, bye bye.